Shall I suggest that we start now? Okay, I suggest that we start now. Is that okay?
Fine.
Okay. So.
Okay, we're now starting.
Okay.
Yeah. First the obvious. I'm sorry I can't be with you directly. Actually, I only found out a couple days ago that I was expected to say something, so this will be pretty informal. I thought it might be useful to just think through some mostly informal reflections about some of the core concepts and theses of the topic, as I understand it at least. For the most part, they're contested quite vigorously, in fact. Sometimes I think rightly, sometimes not. I'll try to give some indication of where and why I think it makes sense to draw the boundaries. Let's begin with the most fundamental question that we can ask about language, namely, what is it? To the extent that we have some partial answer to that question, we can proceed to investigate others, and only to that extent. So, for example, no biologist would try to study the evolution or the development of the eye without some idea of what an eye is. Sounds simple, but rather surprisingly, this question is what is language is not so much contested as just ignored. It's rather curious to see how substantially it's ignored, how casually the question is, the fundamental question is treated in the classical literature, and in fact for today as well. I'll give a couple examples. So take, say, de Saussure, more or less the founder of modern general linguistics. For him, language, I'm quoting, is a storehouse of word images in the brains of a collectivity of individuals founded on a sort of contract. For Bloomfield, major figure in modern American linguistics, language is a set of habits to respond to situations with conventional speech sounds and to respond to these sounds with actions. Elsewhere, he defined language as the totality of utterances made in a speech community. Sapir defines language as a purely human and non-instinctive method of communicating ideas, emotions, and desires by means of a system of voluntarily produced symbols. Moving over to the logical, philosophical literature, the most influential figure in the 20th century to deal with these issues, Van Quine, he defined a language as a fabric of sentences associated with one another and stimuli by the mechanism of conditioned response, hence some finite object. And elsewhere, he defined it as an infinite set of well-formed sentences, a notion which, if it's coherent at all, which I think is dubious, is derivative. It presupposes some finite characterization, some mode of generation, which Quine held it would be folly to try to postulate. Well, within the professional linguistics of the same period, roughly 50 years ago, standard view was what Martin Jost called the Boas tradition, namely that languages can differ arbitrarily and that each new one we approach must be studied without any preconceptions. And the way to study them was by applying analytic procedures to a corpus, typically, maybe solely, procedures of segmentation and classification. So with any of those views, there's almost nothing to say about language and what it is. It could be almost anything. Well, skipping to the present, in a recent issue of the AAAS journal Science, a researcher from the Max Planck Institute suggests that language may just be a constellation of cognitive capacities that have other functions. Other familiar proposals are that language is some rather arbitrary array of constructions acquired by general learning procedures in some recent publications, technical publications, just one procedure, namely statistical analysis of a corpus. Well, it's perhaps understandable that such notions could be considered 50 years ago, but I think it hardly is understandable today. One reason is that an enormous amount has been learned about language and also about its relation to other cognitive processes, including sharp dissociations that have been discovered. And we've also seen by now the complete failure of attempts to work out any of the newer versions. Today, such views merit attention and do merit attention, I think, because of their prevalence and influence, which is substantial, and in my view, at least, only for that reason. That's a contentious position. It's clearly a minority view, but I won't tarry on it. I'll be glad to return to it if you like. By language here, I'll mean I language, a biological object internal to an individual and considered in intention. That is, we're interested in the actual nature of the system, not just its external manifestations. There's another concept, correlated concept, that appears in the literature, namely e-language. I have to admit I'm responsible for the term, but not for the ways it's used, which I don't understand and which don't seem to me even coherent. So I'll just keep to I language. Well, its most elementary property is that it's a system of discrete infinity, hence the study of language, I language, falls within the theory of computational systems, Turing machine theory, theory of recursive functions, all the same thing. An I language can be taken to be a computational procedure, a generative procedure, that yields an unbounded array of hierarchically structured expressions, each of which is assigned dual interpretations at two interfaces, one the sensory motor system, the other what's been called the conceptual intentional system, roughly sound and thought, although we now know that the sensory motor externalization is not restricted to sound and apparently is modality independent. Well, looked at this way, I language captures a classical concept of language as a sound with meaning, or more accurately, I think, a different classical concept, namely meaning with sound, or as we now know, some other externalization. That's a very different matter. I'll return to it briefly. Well, a theory of language has to at least capture these properties, and correspondingly an approach to acquisition or use or evolution of language must incorporate this somehow. For acquisition and evolution, this must be the target that it seeks to attain. So it's quite appropriate for a recent collection of technical essays to have the title Interfaces plus Recursion equals Language, with a big question mark after it. At least this much is required, but maybe considerably more. How much more, that is what the answer to the question mark is, How much more, I think, should be taken as the central research concern of the theory of language. There's one natural research program which begins by assuming nothing more, so no answer to the question mark, and then proceeding to ask how much is left unaccounted for if we take that as the starting point, sometimes called the SMT, the minimalist, simple minimalist thesis. It would assume that the simplest computational procedures are constrained by strong minimalist thesis. I don't even know what the term means anymore. It assumes that this assumption, the SMT, would assume that the language simply is a matter of satisfying interface conditions, externally imposed conditions, in the simplest possible way, the optimal computational procedure. And then we ask, well, what's missing? A research program. The core concept of recursion is often misunderstood in the literature. Quite commonly, it's confused with center embedding, which is a different concept. Similarly, recursion is often incorrectly assumed to be necessarily infinite. That's not true. A recursive function, program for a computer, if you like, may yield a single output, may yield nothing. So, for example, it's quite easy to construct a pseudo-I language that lacks resources to generate more than a fixed number of expressions, or to put it more precisely, a fixed number of non-deviant expressions. I think anyone produces infinitely many. So, for example, we could devise a pseudo-language, let's call it truncated English, which lacks connectives, adjectival modification, relational expressions like, say, father of, and other devices that render normal English unbounded. Now, suppose a child is learning truncated English. Well, the child can't know that it's going to have those properties, so it would proceed exactly as in learning English, but it would find out at some point that there isn't a lot to say. And from the study of children who've acquired language with no input at all, as in Susan Golden Meadows' work, it's a fair surmise, I think, that if a child was faced with such circumstances, the children would probably use their innate capacities to remedy the deficiencies. But if somehow truncated English or some other similarly impoverished system were to persist, it would just be a curiosity. It would tell us nothing about the theory of acquisition, about universal grammar, UG, or have no other interest with the study of language generally. That's a highly contested issue, I think one that should be put to rest. There are, however, interesting things to say about the topic. The most interesting I know were said by the great linguist Ken Hale, late Ken Hale, 40 years ago. And in the light of a lot of recent confusion all over the media, even the scientific journals, it might be useful to quote what he said. Ken, as you know, was studying at that time primarily Australian languages, and I'll quote, he said, conventionalized counting systems, that is numerals, are for the most part lacking, but counting itself is not lacking, in the sense that the principle of addition, which underlies the activity of exact enumeration, is everywhere present. In fact, I would like to argue that counting in this sense is universal, and whether or not a conventionalized inventory of numerals exists in a given language depends on the extent to which exact enumeration is of practical use or necessity to the people who speak the language. One might look, he's, as you know, was studying Walbury extensively, although many other Australian languages. He said that one might look upon the Walbury lack of conventionalized numerals as a gap in the inventory of cultural items, since the principle which underlies counting in is present, and therefore filling the gap is a rather trivial matter. This view, he says, is entirely compatible with the observation that the English counting system is almost instantaneously mastered by Walburys, who enter into situations where the use of money is important, market situations. And this is quite independently of formal Western-style education, he says. Well, Ken goes on to extend the same analysis, similar analysis, to colors and, interestingly, to embedding. And he also suggests provides a very interesting idea for universal grammar about universal properties of relative clauses as adjuncts or center embedded, and make some suggestions about how these would appear in one language or another. Well, among many other unbounded recursive devices, English and numerous other I languages do generate center embedding freely. And if Ken Hale is correct, that's true of all I languages in a deep sense. It may not show up on the surface, but it's there. Of course, without external aids like time and memory, subjects can't interpret such structures beyond some bound. And George Miller and I showed 45 years ago that the bound is about 7, which is what's predicted by Miller's famous magic number 7, plus or minus 2. There's another notion, namely self-embedding, which is much more sharply restricted, not just for memory reasons. So therefore, it's a fact of interest for the study of how perception and parsing take place. The bound of 7 is of no interest. That's just memory restrictions and not human specific. Well, discussion of this topic has often been completely obscured and confused in the literature by failure to distinguish competence from performance, loosely speaking, to distinguish what we know from what we do. What we do obviously involves many other factors, what we know being only one factor. That distinction, too, is vigorously contested, but I think needlessly. It's actually taken for granted in some form in the investigation of any organic system, cognitive systems and, in fact, non-cognitive systems. So, for example, if somebody's inquiring into the nature of the digestive system, they'll ignore the effects of stomach flu or eating a Big Mac or whatever you just had for dinner. Well, all of this, I think, should be truism, and it is regarded as truism, in fact, never even mentioned, outside the study of language, even in the case of other cognitive systems. So take the simplest of these, arithmetic, the one that Ken was talking about. That's an innate capacity that rightly puzzled the founders of modern evolutionary theory, Darwin and Wallace, because it plainly wasn't selected. And in fact, like Australian Aborigines, each person has the capacity to add numbers of arbitrary complexity. But of course, performance will be limited by available resources. In the limiting case, adding numbers in your head by what can be computed with no resources, no external resources of time and memory. Well, one could construct a theory of calculation in the head, along with some elaborate statistical model of how performance degrades or becomes impossible as numbers grow larger. Fortunately, no one undertakes this, at least I hope not. It would, in effect, be a complex list of no interest, as would the same would be true of a description of truncated English without unbounded recursive devices, essentially a list of astronomical size, in fact. We would learn nothing of interest about arithmetical capacity by doing so, and the reasons are well understood. Arithmetical capacity is captured by internalized rules that yields the capacity to go on indefinitely as time and memory are added with no modification of the rules. So there's obviously a crucial difference between a device that stores all calculations internally, basically a list, and on the other hand, a standard stored program computer, abstractly a Turing machine, which captures arithmetical competence with internal rules and access to external memory, like your laptop, for example, or your brain. Superficial experiments might not distinguish the two clearly, but that would just show that they're the wrong experiments, and you better do better ones. Unfortunately, the literature on processing of language by humans or animals, other animals, or machines is replete with failure to recognize these distinctions, which is kind of astonishing. Gee, Randy Gallistel made an appropriate observation relevant to this in his critique of connectionist and neural net models. He remarked that unfortunately, computer scientists sometimes forget what they know about the foundations of physically realizable computation when they begin to think about brains or language, and not just computer scientists. In any event, these are core notions that are contested, but I don't think should be. Well, turn to acquisition of language. Like development of any organic system, it involves several factors. One of them, of course, external data. A second, genetic endowment. A third, more general principles that go beyond language, maybe beyond the organic world. The second factor, genetic endowment, has several components. One of them is language-specific elements, UG. Second is other cognitive systems. A third would be constraints imposed by the structure of the brain, about which not enough is known today to be very helpful. Well, existence of one of these factors is contested, not the others, even in fact denied, namely UG. That must be a misunderstanding. And if you look into it, it's sometimes explicitly based on a confusion of UG, by definition, the genetic component of the language faculty, the genetic basis for it, for I language, the confusion of that with another notion, linguistic universals, like, for example, Greenberg's famous and very important compilation. The latter are generalizations, meaning they may well have exceptions. It's useful to investigate them. UG, however, does not have exceptions, apart from the margins, which we can put aside. So that tells us at least something about evolution of language. It tells us that there's been essentially none in the roughly 50,000 years since our ancestors left Africa. Of course, there's constant historical change, which is a totally different matter. Again, rather surprisingly, these are often confused in recent technical publications. Well, for a computational system like language, the third factor, general principles, can be expected to include at least principles of computational complexity. And as far as I'm aware, virtually all of what's been learned about I language derives from this factor and from UG, assumptions about it, and of course from the first factor, namely external data. Well, again, that's a highly contested notion, but again, I think mistakenly. Well, as in any rational inquiry, we'll seek the simplest theory of UG, trying to eliminate stipulations, avoidable complexity. And from the earliest origins of the modern study of these topics, roughly 60 years ago, theoretical research has been directed towards this goal. In recent years, this research program has sometimes been called the minimalist program, again, a notion that's been widely misunderstood. It's actually just a seamless continuation of earlier inquiry, differing only in that it suggests some new research programs, such as the one I mentioned, adopt the strong minimalist thesis and ask what more is required. I think that's proven a fruitful approach. Notice that there's no question of the truth or falsity of the minimalist program. Those are not the kinds of questions that you can sensibly ask of a research program. And notice also that the minimalist program, as a research program, is theory neutral. Whatever you think is the right approach to language, you can be concerned with the minimalist program as in normal scientific inquiry, or you can decide not to be. Well, a computational mechanism such as iLanguage incorporates somewhere a procedure to construct a new element, call it Z, from elements X and Y that have already been constructed, and to do so without bound. Call that operation merge. Unless there's evidence to the contrary, we of course take merge to be as simple as possible. That would mean it's binary, and it would lack order, and it would lack any further computation, which comes down to saying that merge of X, Y is simply the set containing X and Y. Well, that simplest notion at once raises a number of questions. So one question is, where does order come from? In fact, it is needed at the sensory motor interface along with other forms of arrangement. So one plausible conjecture is that it's kind of a reflex of externalization to the sensory motor system. And if that's true, there are some empirical consequences. It would be expected not to enter into narrow syntax and the mapping to the conceptual intentional interface, the thought system. And at least for core properties of syntax and semantics, there's pretty good reason to believe that that's true. That includes the essentials of binding theory, theta role assignment, other properties, and also an interesting old chestnut that's still around, namely structure preservation of rules. That's actually an interesting puzzle, because the computational procedure that's universally adopted for all constructions in all languages, and adopted without any evidence, the structure preserving principle, so-called, it's more complex, computationally much more complex than an alternative that relies on linear order. That's the puzzle. So to take some familiar examples, you can ask, are eagles that fly swimming? But you can't ask, are eagles that are flying swim? That's a fine thought, actually, and it's much more simply computed than the correct form, but it's expressible only with circumlocution. So is it the case that eagles that are flying swim? Something about the design of language doesn't allow us to use or understand the simply computed form, but only forces it to be a more complex circumlocution. And that has nothing to do with, it's with auxiliary raising, the usual case that's investigated. So take, say, the sentence, instinctively, eagles that fly swim. So we understand that the adverb is not connected to the closest, and in this case, most plausible verb, namely fly, but it's connected to the more remote one, that is structurally closest. These are universally attested facts. They would follow if order is simply not available to the computational system that yields the CI interface. Well, there's some independent neurolinguistic evidence that suggests that that may be true. A research team in Milan, Andrea Moros, the linguist involved, found a couple of years ago that the processing of nonsense expressions observing UG engages the normal language areas, as you'd expect, but not so in the case of comparable expressions that involve order. For example, negating a sentence by moving the third word. That's a much simpler computation than the actual ones, but doesn't seem to engage the language areas, which suggests that subjects are treating these things as a puzzle and not as language. And that wouldn't be surprising from what's known about dissociation of language from other cognitive capacities. Well, this thesis, the thesis that order is part of externalization, that is contested, but in this case it's plausibly contested. There are quite interesting empirical issues. Many of them are brought out in important work of Richard Keynes and Tom Bevers. So what we face is a conflict between quite plausible theoretical, conceptual, and empirical considerations on one hand, and other empirical considerations on the other. It's, of course, not an unusual or surprising feature of scientific research. So that's an interesting and far-reaching thesis, contested, plausibly so. Well, suppose the thesis can be upheld, either in part or fully, which would be the optimal outcome. That would provide additional evidence for a still broader thesis, namely that language is designed to satisfy CI conditions, and that externalization in one or another modality is an ancillary process. That would then follow a fortiori that communication is one of the uses of externalized language, is also an ancillary process, not fundamental to language. I think there's independent reason to believe that. In traditional terms, it would mean that language is primarily what has been called an instrument of thought, the way it was put by William Dwight Whitney. Traditional conception, language in his words is audible thinking, the spoken instrumentality of thought. That suggested shift of perspective is of some significance and runs counter to very widely held modern doctrines, and personally would be inclined to say dogmas. I don't think there's much basis for them. Well, going back to the generative process, the simplest form of merge, the one we accept without evidence to the contrary, has a lot of other consequences. So suppose Y is merged with X. There are two logical possibilities. Either Y is distinct from X or Y is contained in X. Those are called external and internal merge, respectively. Without any further comment, internal merge yields the ubiquitous phenomenon of dislocation and also yields what's been called the copy theory of movement. The reason is that merge leaves X and Y unmodified. That in turn yields a variety of intricate semantic consequences about reconstruction, binding, and other matters. All of them, if you think them through, reducing to the assumption that computation is as simple as possible. A lot of interesting topics there, which I'll skip. Most of you are familiar with them. Well, in earlier generative grammar, it was assumed that composition of elements and dislocation are two distinct processes, and dislocation was considered more complex and hence problematic. That was my view too. But keeping to the simplest theory, we can see that that was a fundamental error. These are just two cases of the simplest compositional operation. There's no basis for saying that either is simpler than the other. And if some theory of language explicitly rules one of them out, that requires empirical justification, because it's an added stipulation over what's simplest. That's contested too, vigorously, but I think incorrectly. Well, given the two freely available options for merge, it's natural to ask whether they have different interface properties. At the sensory motor interface, the distinction is obvious. It's the distinction between dislocation and adjacency. At the CI interface, it's more subtle. The distinction seems to correspond to what's been called duality of semantics. Argument structure on the one hand, which appears to be correlated with external merge, and other properties, discourse-related information structures, scopal properties correlated with internal merge. That correlation appears to be quite close. Whether it's perfect, as I think one might anticipate, but whether it is perfect is contested. But in this case, again, it's a serious empirical issue and much discussed. Well, quite generally, the simplest form of merge with copies yields correct CI interpretations, including a variety of quite intricate cases. But what reaches the sensory motor system is, of course, very different. Hierarchically, the only copy that's pronounced, that's externalized, is the hierarchically most prominent one. Others are deleted. And that again follows from elementary considerations of complexity, namely compute and externalize as little as possible. Well, that yields perceptual problems, what are called filler gap problems in the literature in parsing, and they can be hard. Derivatively, of course, it impedes communication. So what we have is a conflict between computational efficiency and perceptual communicative efficiency. Universally, computational efficiency prevails. They're not an insignificant fact, particularly because there are plenty of other examples. Structural ambiguity, garden path sentences, islands, insofar as they're understood. These seem to follow from efficient computation. Again, they yield fine thoughts that can be expressed only in complex ways. Well-known example is what are called ECP violations. So if you take the sentence, he wondered if the mechanics fixed the cars, you can ask about the cars and the mechanics. You can say, how many cars did he wonder if the mechanics fixed, or how many mechanics did he wonder if fixed the cars? For English-like languages, the second is plainly extremely degraded, and in the cases of languages where it isn't, there seem to be independent reasons, as Luigi Rizzi showed, I guess, about 30 years ago. But you're left with sentences that just can't be expressed without complex circumlocutions, even though they'd be very simple if you could use rules that appear to violate computational efficiency. Well, as far as I know, that conclusion generalizes to all conflicts between computational and perceptual communicative efficiency. That again supports the conclusion, the very broad conclusion, that externalization and a fortiori communication is ancillary to the nature of language, that language is basically an instrument of thought, sometimes externalized, again, a traditional formulation. Notice here that I'm referring to conflicts. Even if these favor computational efficiency, as appears to be true quite generally, that doesn't entail that perceptual and parsing conditions play no role in language design. In fact, there's good evidence that they do. For example, the differential roles of the left and right periphery. Again, these are matters that are much confused in recent literature. Well, proceeding along these lines, we can consider the research program that I mentioned earlier, asking how close the basic design of language approximates a perfect system, one that includes the core computational operation merge in the simplest form and conforms as closely as possible to general efficiency conditions. That would be the strong minimalist thesis again. Any residue would have to be accounted for by complication of innate endowment, either complication of UG or in principle other elements of innate endowment, if that could be shown and has to be shown, or by the task of externalization. That is, relating the internal computational system that yields CI to the sensory motor system. That's a complex task because the systems are unrelated and appear to be quite distinct in evolutionary origin as well. And of course, most is well known, most of the apparent complexity of language lies in the externalization. That's what you have to learn when you're learning a second language. You have to learn the details of phonetics, morphology, order, arrangement, and so on. But nobody learns, and of course nobody's taught, the elements of syntax and semantics with the quite intricate interpretations that they yield without any evidence. Externalization is also the aspect of language that's readily susceptible to historical change, all of which is consistent with what seems to be a reasonably strongly supported conclusion, this very general conclusion that language is basically designed as an instrument of thought. Well, going back to the earliest work in generative grammar, it was concerned with several essential properties, crucially composition, order, projection, and displacement. And the division of labor in the work of the 1960s assigned composition, order, and projection to phrase structure grammar, displacement to transformational grammar. And I think there are good reasons, some of which I've already mentioned, to revise this picture. Composition and displacement seem to fall under merge. Order might be a reflex of the sensory motor system. That leaves projection, nowadays often called labeling. That raises a lot of interesting questions. I can only hint at them here. Suppose we adopt the standard convention that labeling is required for interface interpretation. So you have to know if something's a verb phrase or a noun phrase or a clause or whatever. Hence, if that's true, then every syntactic object transferred to the interface has to be labeled. Optimally, we'd like it to be by minimal computation, in this case a minimal search algorithm, something like agree. That's very straightforward for head XP structures, a head and some non-head. In that case, the head is the most prominent, therefore it's the label by a minimal search procedure, and then the standard interpretive procedures can be carried out without problem. The interesting cases are the XP-YP structures, the cases where you have two things composed that are not heads. That actually is barred by stipulation in X-bar theoretic approaches and their descendants, but that's stipulation. Well, let's suppose they're allowed, the simplest possible theory. One way to render them labelable is to raise one or the other, raise XP or YP. That leaves only the other visible to the labeling algorithm. That's basically a revision of what Morrow called dynamic anti-symmetry, revision of it stated in terms of optimal labeling. Well, we then have two cases to consider. One case is the result of internal merge, which always yields XP-YP structures. Say, suppose we generate which boy did he say John saw. The first stage of derivation, you're going to have which he said which book John saw. In that case, one has to raise, as predicted, and for independent reasons has to be the WH phrase. That's successive cyclic movement. Another case is where it just stays there. It doesn't raise. That's indirect questions. So he wondered which book John saw. Then yet another case is simple subject-predicate constructions, subject XP, YP, and not in X-bar theory where further stipulations are added, but in the traditional approach. In the literature, it's simply stipulated that one of XP or YP is peripheral. One's called the specifier, the other. But that's completely arbitrary. It's an artifact of X-bar theory and its descendants, untenable in a simple merge theory in which the notion specifier is not even definable. There is no notion first merge, second merge, and so on. as there are in X-bar theory with a variety of stipulations beyond merge. Well, in these cases, take, say, the indirect question case. In that case, it's kind of understandable why it would be labelable. The XP and the YP, the WH phrase and the clause, share their most prominent feature, say a Q feature. In the subject-predicate case, they also share their most prominent feature, 5 features, subject spec head agreement it's called. But in both of those two cases, the simplest labeling algorithm will just find the same most prominent feature in XP and YP, and it can label it accordingly. These are the cases that Luigi Rizzi calls criterial positions. Again, they seem reducible to labeling. So the basic cases seem to involve either forced movement, like successive cyclic movement, or Morrow's small clause movement, on the one hand, or criterial positions where you just leave them. Well, there's a lot to say about that and a lot of interesting cases. I'll leave it at that. But that seems to me at least, to be a pretty sensible approach to dealing with a network of issues about projection and reducing them, if this is correct, just to optimal computational procedures. Well, let me finally end up with one other major class of crucial issues, namely, how does language relate to the mind external world? Plainly, it does. You can talk about trees, rivers, persons, and so on. There's a conventional answer, the referentialist doctrine. That's expressed even in the titles of the major books on the topic. So Quine's Word and Object, or Roger Brown's Words and Things. The referentialist doctrine is almost universally accepted, but I think it's a thesis that should be contested. In fact, I think it's completely untenable. Been arguing this ineffectively for about 40 years, so obviously I haven't convinced a lot of people. It is rejected in a lot of classical philosophy in interesting ways, in Aristotle, and much more extensively in early modern British philosophy, which had a lot to say about these topics, I think. I think the neglect that's been forgotten, which I think is unfortunate, by exploring the simplest human concepts, like, for example, the ones I just mentioned, river, tree, person, but in fact anyone that comes to mind, by exploring those you learn quite a lot about the human conceptual apparatus and about how experience conforms to the modes of cognition. 17th century phrase, 17th century British philosophers, a phrase that was adapted and made famous by Kant. These are important questions, and I think they're yet to be systematically explored, though there's many illustrations and examples. It seems that even the simplest words, meaning-bearing elements of language, have basic properties that have no counterpart in animal communication systems. And that's clear beyond any doubt when you move to more complex ones. Well, all of that poses major problems for evolution and for acquisition. It's sometimes proposed that these and similar properties of language compel us to postulate a prior language of thought, but that doesn't help. It simply sets up an infinite regress. Well, assuming a picture roughly like this, and thinking about the emergence of language, apparently recent in human evolution, and it seems with little or no change since, emergence of language would then require some pre-existing interface systems, sensory motor and conceptual intentional apparatus. The conceptual intentional apparatus might include predicate argument structure. Randy Gallistol's recently suggested this in some interesting work. Let's say that it does. If so, then there are at least 3 additional steps required to get to human language. The first one would be emergence of unbounded merge, or if that is not enough, some more complex counterpart. Second, emergence of the arguments and the predicates of human language, which seem to be quite novel. And finally, solutions to the problems of how to link the internal system to the sensory motor apparatus, that last class being apparently ancillary, and that task presumably involving, in part at least, other cognitive processes. Okay, I'll end there. Naturally, these remarks only skim the surface, but they seem to me a fair, if necessarily superficial picture of what things look like as they've developed over recent years, at least from a highly personal perspective. Thanks.